We want to express z squared minus 6z plus 16 as the product of its linear factors. There's a couple of ways of doing this. I'm going to use completing the square. So if we look at the first two terms, we have z take away 3 all squared. But remember, that introduces an extra 9, which we don't want. And then we're adding 16. So that gives me z take away 3 all squared plus 7, which we can think of as being z minus 3 all squared plus root 7 squared. Now, if there was a minus in the middle here, we'd think of it as a difference of two squares. But we can think of it as being a sort of difference, in air quotes, of two squares and make use of I. So what we can do is have z take away 3 plus I root 7 and z take away 3 take away I root 7. And then we can write that as z take away 3 plus I root 7 and z take away 3 take I root 7. Personally, I like to write that as z take away 3 take away I root 7 and z take away 3 plus I root 7. Now we've got some simultaneous equations. Determine the complex numbers u and v, given that 3u plus v is 5 and iu plus v is 5i. So I've got 3u plus v is equal to 5. Let's call that equation 1. And I've got iu plus v is equal to 5i. Let's call that one equation 2. So if we do 1 take away 2, I get 3 minus iu. The v's will cancel out, and I get 5 minus 5i. So u is going to be 5 minus 5i over 3 minus I. So u is going to be 5 take away 5i, 3 plus I, divided by 3 minus I, 3 plus I. If I expand out the top, I get 15, take away 15i, plus 5i, take away 5i squared. And on the bottom, making use of the difference of two squares, I just get 10. So, I squared is negative 1, so that becomes a plus 5, so I've got 20. Take away 10i, all divided by 10, and so u is going to be 2 take away I. I'm going to substitute that back into number 1, and then I get 3, 2 minus I, plus v is equal to 5. So 6 take away 3i, plus v is equal to 5, and therefore v is going to be negative 1 plus 3i.